Woodpeckers! You know what they are. Given that woodpeckers spend all day headbutting trees with their beaks, which are rigidly attached to their skulls, how do they avoid head injury? A human certainly couldn't pound their forehead into a piece of wood without getting a serious headache. First, some basic numbers for scale. When a woodpecker pecks wood, it impacts the tree at 25 kilometers per hour, which is about 15 miles per hour. 25 kilometers per hour is approximately 7 meters per second. The woodpecker's head goes from 7 meters per second to 0 meters per second over the course of about half a millisecond to a millisecond. Acceleration, and thus deceleration, is measured in meters per second, or meters per second squared. 7 meters per second per 0.5 to 1 milliseconds is 7,000 to 14,000 meters per second squared, which is 715 to 1,430 times the acceleration from Earth's gravity, which is referred to as 1g. This analogy doesn't quite work though, since the acceleration from Earth's gravity is a constant force, not a quick spike of acceleration. A more equivalent example would be a bad car crash, which is about 1,000 meters per second squared. Woodpeckers are enduring an order of magnitude more acceleration than even that. Either woodpeckers are extremely durable, or they are all suffering from extreme brain damage. So how do they do it? The reason that a woodpecker doesn't experience severe brain damage is because while their brains experience a large amount of acceleration, they don't experience a large amount of pressure. Force equals mass times acceleration, and pressure equals force divided by area, or mass times acceleration divided by area. Fortunately for mathematical simplicity, both the mass and area of a brain are proportional to the size, or more specifically, radius of a brain. Surface area is proportional to the radius squared, and mass, which is proportional to volume, is radius cubed. Mass times acceleration divided by area can be rewritten as mass divided by area times acceleration. And radius cubed divided by radius squared is just radius. So the pressure is equal to radius times acceleration. Since the goal is to avoid pressure above a certain amount, this means that the smaller the size of the brain, r is, the larger the acceleration it can endure, a is. Just how much more acceleration, you ask? Well, a woodpecker brain weighs about 2.5 grams, and a human brain weighs about 1,400 grams. 1,400 divided by 2.5 equals 560. This is mass, so radius cubed. To find radius, we simply take the cube root. The cube root of 560 is about 8. So, the radius of a human brain is about 8 times larger than that of a woodpecker brain. This means that all else being equal, a woodpecker can withstand about 8 times more head acceleration than a human can. If we take the worst case scenario of 1,400 meters per second squared and divide it by 8, we get 1,750 meters per second squared equivalent in humans, which is still enough to cause brain damage. All else is not equal, however. Animal brains are more or less a hemisphere, and in humans, the flat side of the brain is pointed downward. This means that the part of the brain that absorbs the impact if you bonk your head into a tree is the back half of the hemispherical top of your brain. A woodpecker's brain is rotated like this, such that the flat side of the brain points forward. This means that when a woodpecker pecks a tree, the entire hemisphere part of its brain absorbs the impact. So, relative to its brain size, there is twice as much surface area to spread the force across. Also, the amount of acceleration that a brain can withstand increases the shorter the period of acceleration is. The extremely fast 0.5 to 1 millisecond duration of the woodpecker impact means that the acceptable acceleration is about 4 times higher than in our car crash analogy. So, the relatively smaller brain, oriented with more surface area to absorb the very short forward impacts, means that the woodpecker's acceleration tolerance is about 64 times higher than that of a human. So, doing the math again, 14,000 divided by 64 equals 220 meters per second. 220 meters per second is about 23 Gs. While a human would have a hard time enduring that much acceleration, fighter pilots can only reliably withstand about half of that. This is because our hearts cannot pump blood against that much force. But the acceleration in woodpeckers isn't sustained, so that isn't a problem. Experiments have shown that, ignoring the restricted blood flow, a human-sized brain can withstand about 45 Gs without damage. Woodpecker brains are fine.